Welcome back, everyone. In this video I'm going to go over the third page. That's actually the first page of standard response questions for the final exam for fall semester 2014 for Math 234. Alright, so in this page I'm going to figure out, let's see, first of all, where the lines intersect. So I have two lines. I want to know where do they intersect. So we have to remember, right, in order to have lines intersecting, we need their x values to be the same, their y values to be the same, and their z values to be the same. So I'm going to go ahead and set their x's equal to each other. We're going to set their y's equal to each other. And we're going to set their z's equal to each other. So let's see, 6 plus t equals 1 plus s. And let's see, I have to be extra careful. My 5's look like s's, so I'm going to go ahead and try to rewrite this extra 5y, I suppose. Alright, so there are certainly different ways to solve these, but I'm going to actually use maybe a system of equation. I'm going to use linear combinations here in order to solve this. So I'm going to cheat with technology here and just move this one down a little bit. Oops, I missed my s. That's fine. I'll just rewrite that. And so if I was to take this first equation and subtract away the second equation, let's see what I would get here. So I'd have 4 minus 5, so that would be negative 1. I'd have t minus t, so that would be 0. And then equals 2, so 3 minus 6, that would be negative 3. And I would have negative s minus a negative 2s. So that's going to be the same thing as negative s plus 2s. So that's going to be the same thing as really plus s. Okay, so now I can rearrange. So by adding this negative 3 to both sides, or adding 3 to both sides, I'm going to get s is equal to 2. So actually that was relatively nice. Now at this point I can go ahead and use my s value to solve for t. And I can do this really in any of the equations, but I'll go ahead and use this third one down here. So I'm going to have, let's see, 6 plus t is equal to 1 plus s. And I already know my s value is 2. So therefore t should be equal to 3 minus 6, so that's going to be negative 3 altogether. So this is telling me that s is 2 and t is negative 3. Now we do have to be careful. This says where do the lines intersect? Usually when it says that, it wants an x value, a y value, and a z value. So I have an s and a t value, but I'd like to figure out what are the x, y, and z's that correspond to that. So I'm going to use the first equation here, but you can see you can use either one. But if I plug this into my first coordinate here, so x equals 4 plus t, so 4 plus negative 3, that's going to be 1. Y is going to be equal to 5 plus t, so 5 plus negative 3, that's going to be 2. And z is equal to 6 plus t, so 6 plus negative 3, that's going to be 3. So this is how I would most likely respond. X equals 1, y equals 2, z equals 3. That's where they intersect. And let's be a little bit paranoid here. Let's actually make sure that we get the same result if we plug it into the second one. So if I do x equals, and remember my s is 2, so I have 3 minus 2, that's going to be 1. Y equals, so 6 minus 2s. Again, remember my s is 2, so this is going to be 6 minus 4. 6 minus 4, that's going to be 2. And then finally, in my z component, I have 1 plus s. So 1 plus 2, that's going to be 3. So you can see that we got the same results using either equation here. 1, 2, 3. So, yep, my answer, x equals 1, y equals 2, z equals 3. All right, problem number 12. Given the points a equals 1, 1, 1, b equals 2, 1, 0, and c equals 0, 2, 3, okay, there's no question here. Okay, this is some interesting get. Maybe I can use this space to work or something like this, but here's the first question. A, find the equation of the plane through points A, B, C. Okay, so this is a classic kind of 12-5 problem here. Let's actually get a couple of vectors here. Let's get what is the vector AB and what is the vector AC. Alright, so AB. AB, I start at 1 and I end at 2. How many steps did I take? 1. I start at 1 and I end at 1. Well, I must have taken 0 steps. I start at 1, I end at 0. I must have taken negative 1 steps. Now let's figure out AC. So I start at 1 and I end at 0. I must have taken negative 1 steps. I start at 1, I ended at 2. I must have taken 1 step. I start at 1, I end at 3. I must have taken 2 steps. So I have now the vectors AB and AC. With two vectors, right, two vectors in a plane, we can figure out a third vector perpendicular to those two vectors by taking the cross product. So I'm going to go ahead and take the cross product of these things, and that's going to give me my normal vector, my vector that's perpendicular to the plane. So 1, 0, -1, -1, 1, 2. This is going to be stuff with i's minus stuff with j's plus stuff with k's. So let's see, if I cross out the first row, first column here, I'm going to have 0 and minus a -1. So 0 plus 1. If I go ahead and I cross off the first row, second column, I'm going to have, let's see, 2 minus, and let's see, 1. So 2 minus 1, and then finally if I cross off the first row and the third column, I'm going to have 1 minus 0. So altogether this is going to be 1. Let's see, 2 minus 1 would be 1. Don't forget that negative out there. -1, and then finally 1. So that is a vector that's perpendicular to the plane. So remember, for a plane I always need two things for an equation. I need a vector that's perpendicular. That's going to be my A, B, C. And I also need a point in which the plane contains. So again, my A, B, C, that's going to be my normal vector, and then a point in which the plane contains, well, I can use any one of these points, right? So I'm going to use A here. So let's see, I'm going to have 1 times x minus 1 plus -1 times y minus 1 plus z, or 1, times z minus the z point, also 1. So in this case, the equation of the plane would be something like this. All right, find the area of the triangle ABC. All right, so I need to remember that the area of a parallelogram, right, was given by the magnitude of the cross product. So if you had some parallelogram that was generated by vectors u and v, so here is maybe vector u, here is vector v, and you make the parallelogram, then the area of that parallelogram was given by the magnitude of the cross product. So if you would like to get maybe what is the area of a triangle, right, and now let's suppose this is A, here's B, and here's C. So likewise, I have maybe what AB is, and I have what AC is. Well, that's going to be half the area, right, of the parallelogram generated by those vectors. So I have these vectors AB and AC. In fact, I've already taken their cross product. And so if I take the magnitude of their cross product, so the magnitude of 1, -1, 1, I'm going to get, let's see, the square root of 1 squared, -1 squared, 1 squared, add that all together. That's going to give me the square root of 3. So that would be the area of the parallelogram. But if I want the area of the triangle, I'm going to cut that in half. So this is giving me my final answer is going to be the square root of 3 over 2. Would be the area of the triangle ABC. All right, that's it for this page and for this video. I'll see you guys next time.